Question number 22, properties of bulk matter, Young's modulus. So here it is in an experiment, brass and steel wires of length 1 meter each with areas of cross section 1 millimeter square are used. The wires are connected in series and one end of the combined wire is connected to a rigid support and other end is subjected to elongation. Okay, series of brass and steel, one end connected to a rigid support, maybe a ceiling, and next, subjected to elongation. We need to calculate the stress to produce the net elongation of 0.2 millimeter. So here the net elongation of 0.2 millimeter is required. What we'll do is that if you want a quick, easy visualization, it's something like this is the first one. And the second one, let's say, is something like this. Okay, and this arrangement is subjected to external force, and we need to calculate the stress required to produce the net elongation of 0.2 millimeter. Now here, in this given arrangement, you can easily see that stress through the entire cross-section immaterial, brass or steel, is same because of the given arrangement. Now, let's see, I know that elongation is going to be F by AY multiplied by L. That's how we calculate the elongation. And F by A, let me call it as stress, denoting it by sigma multiplied by L upon Y. So now this is the calculation of elongation, and individually let's add the elongation, and that has to be equals to 0.2 millimeter, what is given by the question here. So the calculation would come something like this. Delta L net will be equals to sigma L by Y1 plus sigma L by Y2. You see, in both the situation, the length is same. In both the situation, the stress produced is same. So there is no point of giving a subscript of 1 and 2 to sigma and L. Now, just delta L net 0.2 millimeter, Y1, Y2 is given, put the value of L, but the calculation, the value of sigma that comes out from this calculation matches with no given option. So to the best of our knowledge and calculation skill, none of the given option match with the one that comes out from calculation. All right, let's proceed to the next one. The 23rd one from electromagnetic induction, RL circuit, and specifically about the current building up in a RL circuit. Let's see, a coil of self-inductance 10 millihenry and resistance 0.1 ohm is connected through a switch to a battery of internal resistance this much. After the switch is closed, the time taken for the current to attain 80% of the saturation value. Generally log 5, we don't remember it, so the value has been given. Otherwise, when it comes to log 2 in both the base, the natural and the 10, we remember it. So here, just for the sake of simplicity, it has been given, and it is something like I equals to I naught 1 minus e raised to the power minus RT by L. That's the RL charging equation. Now let's see, it says 80% of the saturation value. That means this is going to be 4 by 5 times I naught, and that will cancel I naught into 1 minus e raised to the power. Now R and L, let's see. R would be the battery resistance and the coil's resistance. Both would occur in series, so they need to be added, 0.1 and 0.9. That's of course 1. And L, let me keep it in millihenry itself, so that the time would be in millisecond. And you get that as R as 1 and T will keep it as it is. L is 10 millihenry. So whatever T I get from this equation, that would be in millisecond. And I can easily convert it into second. And the correct option for this is going to be option number 4. Okay, now let's move to question number 24. 24th is another straightforward question just to calculate the magnetic field by a current carrying arrangement. And here it is, magnitude of the magnetic field at the center of an equilateral triangle, and the side is given as 1 meter, and the triangle carries a current of 10 ampere. That is there. Let me just construct an equilateral triangle, so very closely to an equilateral one, and the side, let's say, okay, the length is given as 1 meter. Let me keep it as L, and we need to calculate the magnetic field at the center. So that's the centroid, and to see where the centroid lies, it would be straightforward at this given point. Here is the centroid. Let me call this as R, the centroid. So I get R as 1/3 of root 3 L by 2, because root 3 L by 2 would be this, L sine 60, and 1/3 of that. So I got the value of R, which is L by 2 root 3. I need to calculate the magnetic field at the center, so a bit of additional drawing here again. So from here I go this point, from here I go this point. That's where we require the angle for the sake of Biot-Savart. This is 1390, so this has to be equals to 60 degree. There you go. I now have all the parameters. Now the magnetic field at the centroid due to this is going to be mu naught I by 4 pi r sine 60 plus sine 60. So that's going to be 2 sine 60 is the magnetic field due to this. Due to this, the direction would be same and the magnitude is equal. So quite obviously, I need to multiply it by 3 to get the net magnetic field. A slight bit of calculation, and the calculation is not at all tough. You do it, be careful with the unit. You're going to get option number 1 as the correct option for 24th question.